It's 1189. You take the sample and subtract the mean. So 1189 minus 1272.22. So I'm going to do that in another screen here so that I have it. So in this case, it's a negative 83.22. And then you end up squaring that value. So some students need this to be shown in like different columns, but you can actually do it all in one column if you want. It gets, and the numbers get pretty large, which is why, again, I'm kind of surprised that your instructor wanted to do these by hand. So then you repeat for the next value. You grab that next number, 1271. And you do the same thing, 1271 minus the 1272.22 and so on. So here we go. That ends up being minus 1.22. And when you square it, you get 1.49. And so you repeat this process for all the values in the data set. So what I'll do here is I'll just put the results, if that's okay, on the, well, actually, you get the idea. I mean, I think that it's very much a rinse and repeat here. You take that data value, you subtract the mean, then you square it. And when you square it, you get a bunch of numbers over here on the right. So the next thing is to add them all up. You have to add everything up in the last column here. Pretty exciting, I know.
Yeah.
So that's 10909.56. So the standard deviation formula, sample standard deviation formula, is the summation of the sample minus the mean squared. So that's this number here over n minus 1. So it's the number of samples minus 1. There were 9 samples. 9 minus 1 is 8. And then you take a square root of all that.
That's
And
for
then
sample standard deviation.
yes, exactly. So it ends up being 37, 36.9, 37, like that.
All right.
All right. Question 3, 9% confidence interval. So there's a formula for confidence intervals. You take the mean and you add and subtract the margin of error. The margin of error is the following. It's the z alpha divided by 2 times s divided by the square root of n. Which again, pretty interesting, of course. The rough and dirty calculation here is that when it's a 90% confidence interval, what you're saying is that there's 5% in each tail. And the z-score there is 1.96 and minus 1.96. So 1.96 times the standard deviation you just found, which is, what did we just say? 37 divided by the square root of 9. It's the number of samples. And so the mean was 1272 plus or minus this margin of error. So we're going to calculate that now. Oops, be helpful if I did that correctly. All right, so it's 24. This is roughly 24, so plus or minus 24. So when you add 24 to it, you get 1296. When you subtract 24 from it, you get 1248.
All right.
All right. So check those.
I'm gonna submit it right now.
Okay, sounds good. Whenever you're ready, if you want to share screens again, we can look at some more questions or whatever else your mom wanted for tonight.
Oh man, it said The last one was wrong.
Okay. Well, we'll look at that another time. I don't know.
That sucks. All right. I'm gonna go back to quizzes or content. Maybe.
I probably used the wrong number. That's probably why. I think it's 1.645.
Oh,
That's okay. One, what else we got here?
I think we got these two confidence intervals.
Okay.
Well, I guess they're all confidence intervals.
Okay, sounds good.
Okay, let's see. Oh, that's a bit. Can you let me try to zoom out? Can you see everything?
Yeah. We can actually do this one without even taking a snip. So the 95% confidence interval, well, they're all the same. So the number of samples is how many? One, two,
One,
three,
two,
four.
three, 4, 5, 6, 7, 8, 9, 10.
So it's one of the last two. And then because this is, let me look. So this is a what's called a T distribution, but uh, you think your mom will want explanation on this?
Is it because, let's see, the bottom number you said was n minus 1?
It's N in this case.
This n? Okay, so
Yeah,
that's 10.
I'll just grab a snip of this. I probably
Okay.
shouldn't try to we shouldn't do it on the fly. So go ahead and go down to number two.
Maybe if it was me, maybe it would be. You probably got to see it.
All right, you want to go to number two? All right, could you zoom in just a tiny bit more now?
Here.
Maybe another one. All right, that looks good. All right, so next one here. Okay, let me grab number 3 and 4. I'll grab those together. All right, I got them. If you want to scroll down to 5, hopefully I grabbed them. Yep, did. All right, you can scroll down. All right, here we go. Okay, so I'm going to share my screen and we'll continue
Okay.
this one. All right, so for a given sample, the confidence interval calculation is X bar plus or minus P now alpha divided by 2 times S divided by the square root of N. So since N equals 10, that's what I was trying to say is these two are out because they all have the wrong bottom here. Now, the only difference between these other two are this number right here. And that comes from what's called the T distribution, which looks a lot like the normal distribution. The degrees of freedom is N minus 1 or 10 minus 1 in this case, which is 9. And so we're looking for a 95% confidence interval. So that's alpha equals 0.05 divided by 2, which is 0.025. So we're looking for that number with 9 degrees of freedom, basically. And you look this up in a table, which don't worry about sending that over. But if your mom is here, I would definitely say, hey, let's look it up in the table. But without her sending over, I don't know what she would have. So the E dot inverse 0.025 comma 9 degree freedom. So this number ends up being 2.262, the T value. So T of 0.025 comma 9 ends up being 2.262, which is why this third one is correct because it's got the right T value in front there.
Okay.
All right, so this one, boy, I hate the they want a certain language, and it always starts out. We are 95% confident that the true population means this one is for sure correct. The we are 95% confident. And then we're choosing now between these other two. Like this is a first, this one we're checking here is a pretty much a recipe. They always are the same. Um, so the confidence interval is always on the population. So the only difference between these two is population and sample. So I believe these two are going to be correct because it's a confidence interval on the population versus the sample. All right, number
Okay.
3. So these are classic test questions. Increasing the sample size would, so you have to look at where it falls in the formula. It's 1 over square root of n. And so we're looking at like what is 1 over the square root of 9 versus 1 over the square root of 81. Well, 1/3 versus 1/9. Okay. What happens is you're dividing by a bigger number. So it actually makes the confidence interval smaller, which is actually what you want. You want it to get smaller. So that's why you sample more in those situations. All right, so the sample mean is the center of the confidence interval. This is always the center. So changing it has no effect on the size of the confidence interval. It's just the center point. Doesn't do anything. It's useless. And these are all kind of like definition stuff. So
Need some.
increasing the sample standard deviation. So the margin of error is the t alpha over 2 times s divided by the square root of n. So as s goes bigger, as s goes up, the width also goes up. Because you could imagine, like, let's say the sample standard deviation is 1 and then it's 10. Well, multiplied by 1 isn't as bad as multiplied by 10. So it gets bigger when this goes up. All right, increasing the confidence level, that's the C value. When the C value goes up, the interval gets wider. And the reason is the P alpha divided by 2 number. This number gets bigger as C gets bigger. So it makes the confidence interval larger. These are all just pure definitions. There's not really like much else to say on these.
For number 5, you said increasing the standard deviation would increase the confidence level, right?
Yeah, the confidence gets larger.
Thank you.
All right. Next one here. If we could justify using the normal distribution, so this the student P distribution, then the confidence interval would be it's either slightly smaller or slightly larger. So essentially it's like, how do we compare the Z 0.025 versus the T 0.025? We kind of already did this. So the T 0.025 was 2.262, that number, and then the Z is 1.96. So you can see that this one produces, the T produces a wider and the Z is a slightly narrower. So if we could use the normal distribution, it would be slightly smaller or narrower. Narrower is kind of a better word for that.
Okay. I'm gonna turn these in and
Okay, sounds good.
got 100.
All right.
Good stuff. Okay.
So there's one more maybe.
Yes, just one more.
Okay.
How long is this session? Is it 30 minutes or an hour?
We got another 20 minutes. We're
Oh,
okay on time.
I'm
I'm
gonna
sure you're
share my screen with you.
all right.
I think it was Corso. Confidence. Okay, I got it. Well, this is long.
Bunch of questions here.
Yeah, seriously, right?
That's all right. Okay, I got the first one. Gonna scroll down to the second. All right, I got the second. Third. We got the third.
You have the third one?
I do not. Sorry, if you could go up to
Oh,
the third, please. Thank you.
okay.
Okay, go down for the fourth. All right, I got that one. All right, yeah, I need that kind of pre stuff there. All right, so I got five.
Did you get 6 too?
No,
Or-
just scroll down. I get 6 and 7 here. All right, got them. Okay, got it.
Got it?
All right, I got 9 and 10. All right, I got 11 and 12. Last one is true. That's just a straight definition. You want to mark that. All right, let me share my screen. Okay. All right, so some sort of question here. It says a small group of 15 hummingbirds and the average weight is 3.15 grams and the standard deviation is 0.33 grams. So those are just the numbers we're grabbing from there. Is it appropriate to use a normal distribution to compute a confidence interval? The answer is no, because we don't know the population standard deviation and we also have a small sample size. So, I mean, in case that this one's wrong, I will just adjust it, but I don't know why it would be. But typically these are violated. These are really important. So, okay, let me grab the next one here. Next one uses information from what we just said there, so I need to grab these values. All right. Okay, so the 90% confidence interval means that your C is 0.9, your alpha is 1 minus C, which is 0.1. Alpha divided by 2 is 0.05. Your degrees of freedom is n minus 1 or 15 minus 1, which is 14. This is all set up to calculate here. So the margin of error is the T alpha divided by 2 times S divided by the square root of n. That T is the big one. It's the degrees of freedom and the C. I'm going to go grab that for us now. This would definitely be a good thing for us to look at on a table at a later time. So this ends up being 1.761 times 0.33 divided by the square root of 15. If you have a calculator handy, you want to try that, you can. Let me grab mine. All right, so it ends up being 0.15 perfectly, which is bothersome. I wonder if the teacher used a normal distribution. Hmm. I think I want to change the answer to number one because the answer to number two doesn't really follow. Um, because this number right here isn't the same as any of these, which is weird.
Hmm.
So, but when I change it to when I change it to a Z alpha over 2, this changes to 1.96. And then it does work out. It ends up being 0.17. So I guess I'll go with this one.
Okay. So we're saying yes, or
Yeah, and I guess I guess because of the words here, it says it has a normal distribution, so I guess we're okay.
okay.
Okay. Um, the next one here is a formula to find the sample size. The sample size n is it's the standard deviation times the z alpha divided by 2 over the margin of error squared. This is just a formula. So we know that the standard deviation is 0.33, the alpha is 1.96, the alpha and the margin of error is 0.08. And then you square it and round. And so this ends up being 65.367, but you round up to 66. So I guess that I skipped one here. So let me go to the one that we shouldn't have skipped. The one that we shouldn't have skipped, these always follow a recipe. It's always the we are 90% confident. So and it's always that it contains the population. The first one's out because it doesn't say we are. The second two, the only difference is in the population sample. The confidence intervals are always on the population. All right, next question here. So suppose X has a mound-shaped symmetric distribution. So it's saying something like that. Random sample 16, sample mean equal to 10, and a standard deviation equal to 2. Is it appropriate to use the student's t-distribution to compute a confidence interval? Well, we do that in the next step. So I guess we're going to say yes to that question. I'm not sure that all the conditions have been met, but that's what they want. So we'll go with that. Now to
Matt,
actually
what
count,
oh,
what
sorry. What did you say number three was for the
we
intake?
are the middle one. We are 90% confident.
Okay. Gracias.
No problem. Are you caught up to this question?
Yeah, questions.
6.
Yep.
Okay. So we need these pieces of information here. Okay. So the 10 is right in the middle. It's gonna be 10 plus or minus. Now we've got to find the p value from the table. So the 95% confidence interval is 0.025, degrees of freedom 15. We're gonna look this number up in software. Ends up being 2.131 times 2 divided by the square root of 16. So that's 8.93 on the left. And then when you do it on the right for adding it, so there's just two calculations here. Ends up being 11.07. So that one looks good to me. Okay. The next question here is the interpret. So it's always a we are 95% confident. So it's either the first or the second. Population versus sample. It is always about the population. Always, always, always. All right, so we did a problem like this earlier where we had to find the sample mean and the sample standard deviation. Just a quick look, the sample mean is probably 9.95 because of the numbers. But we can get rid of actually, this one. But standard deviation is that long calculation we did before, which we can just not do just because we know how to do it. Make sure we get all these in tonight. So it ends up being 1.02 is the result there. Any questions on that before we proceed?
No, but sorry, number 7 was we are 95% confident that the confidence interval contains population mean. Okay, oh yeah, you're showing me. Okay, thank you.
Right. So this one, 99.9% confident. Wow, it's a big one. It's probably going to be the widest interval, but that's probably not like a guarantee, so we shouldn't do that. We're going to reuse information from here. 9.95 is the X bar. S is 1.02. So your C is 0.999 and your alpha is 0.001. You divide that by 2, and you get 0.0005. Degrees of freedom is, I didn't even count how many were in the sample here. There were 10. So degrees of freedom is 10 minus 1 or 9. Okay, so we got to look up that value again using software. There's not really a better way to do it. Point, it's just 0.0005, comma 9. All right, wow, that's a big one. 4.781. So it's 9.95 plus or minus 4.781 times the standard deviation 1.02 divided by the square root of 10. And it ends up being 8.41. That's the smallest one, kind of like I said, and the other one will be 11.449, like that. All right, number 10, since all values in the 99.9% confidence interval are above 6, we can be almost certain that this patient no longer has a calcium deficiency. I'll just say true. I have no idea if that's really how it works in the medical field. You actually might know better than me if that's true. All right, number 12 and 13, sorry, number 11 and 12 are both table lookups. So the 95% confidence interval corresponds to an alpha of 0.05. When you divide it by 2, that's 0.025. Degrees of freedom is n minus 1 or 11. So you're just looking this up in your T table, 0.025, and then degrees of freedom 11. So I will do that now. ends up being 2.201. And then the last one here is very similar, just different numbers. Let me grab a snip of it. All right, so same thing here. C is 0.9, which means alpha is 0.1 divided by 2 divided by 2 is 0.05. N is 22, so the degrees of freedom is n minus 1. So we're looking that up in our P table again. Degrees of freedom 21.05. All right, 1.721. Look at that, option A again. And then the last one was a definition there. So why don't you check and see if there's any issues with any of those before we close out for today?
Okay, so it says we missed 4.
Okay, why don't you share your screen and we'll maybe be able to figure those out quickly with
Oh, just 2. 2, sorry. I guess it just took off 4 points.
interesting. So um so the value I first got was the 0.1, closer to the 0.14. Boy, that's really upsetting. 14. Let me look up something here. Yeah, 1.645. Is that what I used? Why do I keep using the wrong one? Wow. Okay, that one's on me. I definitely used the wrong value on that.
Well, at least you know.
Yeah. All right. It is letter C for number 2.
0.14 margin of error.
Yes. Yes. And that does affect the next one. I don't know why I used the wrong number there too. You ever get tired? That's what's going on here. All right, it ends up being a 47. I'm going to use the correct number for that.
Okay. Are we confident on that one? Hey, because confidence intervals. Okay. Anyways, I need to go to bed.
Wow,
I
those are dad jokes. You're well on your way. I think those are pretty solid.
okay. Solid.